Well, good morning, everyone. It's Friday. Always a reason to be thankful. Help me say hi to Mr. Pratap. Hello. Anyway, in the last lesson, we looked at some quirky experiments, right? For example, this experiment here where we cover part of the leaf with a black piece of paper to find out is light necessary for photosynthesis, right? Here there's no light and here there is light. Well, in this video, we're going to look at a slightly different type of experiment, which is over here. And this experiment helps us to explore a deeper question, right? Not just whether light is necessary. That means not just got light, no light. But we're going to look at different light intensities, right? How do different light intensities affect the rate of photosynthesis? And we're going to look at the effect of varying light intensity, not only light intensity, but carbon dioxide concentration, the amount of carbon dioxide, and also the temperature. When we vary these factors, how do they affect the rate of photosynthesis? And how do we study the rate of photosynthesis? What is the design of the experiments? What equipment and apparatus is used? And finally, at the end of this lesson, you're going to look at this important concept of a limiting factor. Super important especially for pure bio, to understand what this is. So I want you to start with the notes number 2, and you will see this diagram here. Now this diagram shows the setup of an experiment that is used to investigate the effect of light intensity on the rate of photosynthesis. Now I want you to think for yourself for a while, how does this experiment work? What are the different pieces of apparatus for? What do they do and how do they work? So think about it, pause for a while, and I'll explain in the next few slides. Well, maybe your eyes first fixed on the lamp and the meter ruler, and you ask yourself, what's that for? Well, the lamp and meter ruler actually allow us to vary or change the light intensity. So here's our plant here. Imagine if we put the plant very near to the lamp. Well, the light intensity would be very great, right? Because it's very near the lamp. Right, but as we place the plant further and further from the light source, or as the distance from light increases, the light intensity would decrease, right? As I move this plant further and further away, you'll get a less and less intense light. And the meter ruler just allows me to measure how far the plant is from the lamp. So that lets me conduct my experiment. I can put the plant very near the lamp, measure the rate of photosynthesis, then put it at different distances away from the lamp, and measure the rate of photosynthesis at different distances. Now, maybe you focus first on the fact that there was a plant and it was under the water. Now, how can the rate of photosynthesis be measured using this plant? Well, hopefully you remember something from your last lesson, that we can measure the rate of bubbling, right? And what would these bubbles be? The plant would produce some bubbles after some time, and those bubbles would contain oxygen gas, right? Because oxygen is produced in photosynthesis. So we can measure the rate of bubbling to measure the rate of photosynthesis. So the slower the bubbles are being produced, the slower the rate of photosynthesis. But if we see many bubbles being produced very fast at a high rate, then the rate of photosynthesis is very high. And finally, you might have been quite puzzled at what this kind of beaker or tank of water is. Why do we place a tank between the lamp and the plant? Hint, it is to keep a variable constant. Well, this tank actually helps to keep the temperature constant, because temperature also might affect photosynthesis. Now, when the plant is placed very near the lamp also produces heat, and that heat might actually affect the photosynthesis. So to prevent that from happening, we place a tank here to absorb the heat, to keep the temperature constant. Now I've talked about how we can investigate the effect of light intensity on the rate of photosynthesis. I would like you to also read your textbook on how we can investigate the effect of temperature on the rate of photosynthesis and different carbon dioxide concentrations on the rate of photosynthesis. There are many experiments, setups that can be done. You can look at this page of your textbook after everything, okay, at the end, to find out about what are the kind of experiments and the setup that is used and understand that setup as well, because it might come out in the exams, or different setups might come out and you need to understand it. Alright, but for now, we're going to do an activity together. Hooray! You should have been given a handout called Nutrition in Plants Activity 1, and you'll need to go to this website to see a simulation. So you can find the link to this website on my tiny URL, or you can just type it in. This simulation will help you carry out this experiment, right? Because we cannot go into a lab, but you're going to try this experiment out on the simulation. So I'm going to show you how it works in just a bit. Okay, if you have opened up the website, then it should look something like this. Right, here's our underwater plant. In this case, the plant is called Elodia. And here's our light source. Here's our meter ruler. So you can actually drag the position of this light source. The closest you can go is 100 cm. And this is the greatest light intensity. Right, I can also drag the thing back all the way to 200 cm. Right, that's the furthest I can go. That is the lowest light intensity. Okay, I'm going to show you an example using 150 cm. Right, once you've chosen your distance, click Start. And it zooms you in onto the plant. And you see the oxygen bubbles being produced. Boop, 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 boop. And what you're supposed to do is count the number of bubbles that are produced in 1 minute. So that will give you the rate of photosynthesis in bubbles per minute. You either use this to count how many bubbles in 1 minute, or you can tap. So like every time you see a bubble, tap, 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 tap. And that gives you about 60 bubbles per minute. Alright, so do that for different distances. And I would like you to fill up the table in your activity 1. Right, here's the table. So for example, put it at 200 cm. Measure the rate of bubbling. Okay, 160 cm and 120 cm. So just try it for these 3. Now once you're done trying out the experiment, I have given you a set of data on the second page where you see distance from light source, light intensity, and rate of photosynthesis, bubbles per minute. So this data here is for you to plot 2 graphs. The first graph is plot distance from light source against rate of photosynthesis. So put distance of light source on the horizontal axis and rate of photosynthesis on the vertical axis. Alright? Now the second graph I want you to plot is light intensity against rate of photosynthesis. So that's this column against this column. This one on the horizontal, this one on the vertical axis. Now you might wonder, right, I could get this from the experiment, right, distance, because I used the meter ruler to measure distance from light source. But how do I get light intensity? Well, it is arbitrary units. So you notice that as the distance from the light source decreases, that means my plant gets closer and closer to the light source, the light intensity increases. Now what I did to get light intensity is a bit cheapo. I just took 200 minus distance. So 200 minus 200 gives me 0. 200 minus 180 gives me 20. 200 minus 160 gives me 40. So basically I reverse it. So all the big distances become a very small light intensity, right? Because the two are kind of inversely proportional, right? The closer I go, the greater my light intensity. Alright, but if you didn't catch any of that, don't worry. Just use the data to plot 2 graphs. Alright, so first graph is this against this. Second graph is this light intensity against rate of photosynthesis. Alright, have fun with the activity. Remember the skill alert, what's important in drawing your graph. I would like you to do a line of best fit. Okay, a best fit line. Okay, don't join point to point. Right, here's where I want you to plot the 2 graphs. First graph and then second graph. Right, once you're done with the graphs and activities, it shouldn't take you more than 20 minutes. Alright, go back and watch the next video and we'll discuss the results. Cool.